Hello and welcome back again to Calculus 3. This is section 12.2, part 2. So our internet exploded and now it's all put back together. Let's see if it holds up till the end of the lecture. We're talking about the domain. We said that in our 3D functions, domain is now two-dimensional, x and a y, which is the entire xy plane that we know from our previous life. And range is housing only z variable. So now we are looking at function, the domain of square root of x minus y. And you already suggested the answer because you thought about it for like 6 days till the internet came back. Well, it was equivalent, right? You know that to find the domain of square root, you take the argument, which is what's under the square root, and you set that larger or equal to 0. You can only take square root of positive numbers and 0. That's why you set it this way. And then you just ship y to the other side. You get that x is larger equal than y, or y is less equal than x, just because we can. So now, this is actually the domain. It is enough for you to state the domain is set of all points x, y, such that y is less equal than x. This is actually the notation. There is nothing else to write. And to understand this notation, you can draw a graph for that particular domain. You see that you are supposed to graph y equals x and then shade one side of that line. These types of problems were in algebra. So we are going to draw a solid line through 0 because the points on that line are included. And then we need to shade all of the values where y is smaller than x, which would be below the line. So that would be the domain. Now, any point you pick from the shaded region, you will be able to compute function for it. And any point that you pick from the non-shaded region, you shouldn't be able to compute function for it. So you can try -1, 0, and 1, 0. -1, 0 would give you square root of -1. And 1, 0 will give you square root of +1. So, as you can see, they work. So that's the story of the domain, right? And you, let's find more. I mean, since you love it so much, let's take a look at 2 more. So how about function g of x, y, is given as ln of x squared minus y. So the rule for ln is the same as the rule for square root, except over here you cannot include 0. So to find the domain, we are going to set x squared minus y larger than 0. That's it. No equal. From where x squared is larger than y, and then we write y is less than x squared. So what is the domain? Domain is set of all points x, y such that y is less than x squared. And if you want to draw and shade, you will draw parabola and shade where? Inside or underneath? Outside, yes. So you would shade outside. All right, one more for domains. We should get something that it's a bit spicier. Ooh.
Can you find some spicy there?
There are two, yeah. Let's go with 12 and then we'll probably do another one. This is fun. So how about the cosine of x squared minus y squared? How cool is that?
It's going to get to the side of the ball.
Yeah.
I can't remember the thing for a second.
So what's the answer? That's all I hear.
You have to set x squared minus y squared.
And what's the domain of cosine?
Negative 1
I
and 1.
don't remember.
Negative 1 and 1. No?
Oh, God.
Yeah?
Okay.
No? What's going on?
What's going on? 12.2, part 2.
Domain is just what you can plug in. All of that. I was sitting here thinking I was
So just remember, you can plug in anything into cosine. The range is between -1 and 1. So over here, domain, all xy element of R2. Now range is going to be -1 to 1 because it's cosine, and that's all the cosine can give back.
What exactly does, so is that notation, does that work for multiple types of?
Well, this just says that all points. You can write all points.
If you were in R3, you could write it the same way.
X, Y, Z element of R3.
Okay.
One more, and then we'll move on. We have one more short concept after this, and we're done. So how about g of xy is equal to square root of xy divided by x squared plus y squared.
Thanks.
Well, thank you. I work hard. Not.
I think it's the other way around.
Yes. I love reading essays.
That could have been sarcasm, but I'm still doing it. Pretty sure it's
Why are you all so negative all the time?
Mark, not an English teacher
When you're negative.
However, I worked as a bouncer one time. So.
Yeah.
Unless you painted different color.
They were so cute. It's like I crossed her and himself once. So it's like, I could do it for you. Dreading? God. No. That's really hard. Right? And it hurts. I just ice this face real quick and just watch that.
So standard setup, it's a square root. So whatever is under the square root needs to be set to larger or equal than 0. And then we have to grind through whatever calculation comes out of it. So we have xy, x squared plus y squared greater or equal than 0. Yes, equal. Right. Because square root of 0 is 0, so that's okay. Now when you cross multiply, we just get xy larger than 0. And these are the values that are allowed.
Oh, that makes sense. With the words or something. Can't x squared plus y squared also not? Isn't there a specific?
X squared plus y squared
Since you're adding the denominator?
can never ruin this because it's plus. If it was x squared minus y squared, then yeah, we have issues.
What would you do in the situation it was x squared minus y squared? Would you just
I would make sure that that's never 0. I would say, and
separate? Okay.
yes, there is another part that we have to exclude all of the points that would make that 0. Where technically plus minus x, x equals plus minus y or whatever, whichever way you want to. Now, what should I do with this?
Then you can split it into x squared.
Oh. It says the product is equal to 0. I mean, product is larger than 0. That means that we are only looking for the product to be positive. So, domain is xy such that their product is positive or 0.
So it's only going to be able to be in 2 quadrants? I don't
Yes.
understand what you wrote. Positive.
So if you look at this statement, right, the product needs to be positive, so you can multiply 2 positive numbers or 2 positive numbers or 2 negative numbers, and that will give us, right, and then or zeros. So if you are to graph this thing, yes?
Why did you ignore talking about x squared plus y squared? Shouldn't it be different to 0?
It cannot be.
If they're both 0. They're both 0.
Oh yeah. Yeah, we have to exclude the origin. Good. Yes. So we are going to exclude the origin, but we are going to include the axes, and we are going to shade this part and this part. So if the product is positive or 0, but not both 0, because the denominator, yes, you're right. Well, now I need to add to my essay. So the product is positive. Okay, so let's go in detail now. So the product of x and y is positive or 0. X is not. X and y cannot be 0 at the same time, because that will kill the denominator. There we go.
But isn't there a situation
The x not be negative than a comma?
Yes.
Could not be 1.
Cannot be 0 at the same time. There you go. The only thing that is left is level curves. Level curves are going to be useful to understand shapes that are 3D from 2D perspective. So what I'm going to do now is I'm going to take any 3D object and I'm going to slice it with equidistant z planes, which are xy planes, right? So z equals 0, z equals 1, z equals 2, z equals 3, z equals 4, z equals 5. And then I'm going to look at the level curves, which are whatever is outlined once you do the cut. If you remember when we cut the watermelon, right, one of the cuts was the z equals a number cut. So it outlined the ellipse. Now, if you are to observe a watermelon and you take the watermelon on the side and then you really slice it with z-planes, you are going to see something that looks like this if you just plot the, or egg, whatever. Avocado, fine.
Oh, a tree.
So, a watermelon has been cut. I did. We're going to make a better one. There we go.
How to make him self-conscious about his drawing? Come on.
So there's the watermelon or the potato. Whatever. So X, Y, Z. And you slice with planes. This is what you are going to get in the XY plane. So these circles, ellipses in this case. These are called level curves. And this would be z equals 0, z equal 1 cut, z equal to 2, z equals to 3, z equals to 4, and so on. These level curves are very useful because they show the object's rapid change in steepness of its sides. Clearly, one of the largest uses would be maps. Now, I can't make this any bigger, so I hope that you ate enough carrots and beets in your life to actually see that these lines over here are very dense, and lines over here are far apart. When you have lines far apart, that shows the smaller steepness of the 3D object, because the cut to go the same amount of height up will have to travel further out to intersect the object. So if you have an object that doesn't have too steep of a slope, when you do the cuts at equidistance, you have to go further out to get to the next line, which shows the intersection between the plane you're cutting with and the object you're cutting. So when you're looking at this, and let's say you want to go hiking, right? You will look for the path where these lines are furthest apart as far as possible to avoid very steep hike, right? So you can, navigate here. Also, obviously, if you're driving off-road, right? Let's say military purposes and so on, right? Then the maps would show things like that. Here is another example. So this is, you see the graph on the right, and what you see is the way the cuts work, right? It creates all of the cuts. So I don't know, z equals 0, z equal 1, z equal 2, z equal to 3, and the point on top z equal to 4, which again would give us circles or ellipses. The shape so there are more interesting shapes. You can take a piece of paper, bend it in the shape of parabola, and put it slanted. That's the next shape that you see in the textbook on page whatever. What do we have? 878. This is the same as previous example. This is very interesting. If you look at your level curves, right, there are a set of parallel lines. Look how wavy the object is, right? Now, there it is. electric potential function. Also, you can say, all right, these are termite nests. It's fine, whatever, colonies, right? Please observe the way that, right, these are far apart here, which means there is no issue to walk that way at all, right? Because the level curves are far apart, so there is no steep climb. But then if you try to go one of these stacks, look at that. They're very dense, so that means it's very steep. So you have various configurations for level curves. It's just important to know that you are cutting the object with the equidistant z-planes, and then that the floor, the xy plane, is z equals 0, and then you can cut every inch, you can cut every tenth of an inch, you can cut every mile, depends on what you're doing. So now we can generalize this to functions of more than 2 variables, because we can have as many as we want. So in general, so more than 2 variables. So what do we have? We have good old y equal f of x with 2-dimensional realm, so R2, and its associated coordinate system xy. Then we have z equals f of x y, which is R3, and we know also that coordinate system because we used it. Yes. So now we have w equal f of x, y, and z. Now this is going to be R4. We don't draw this. You can actually draw it on 3D and use the color to indicate the 4th dimension. And this is actually used. The reason why I didn't switch is because I wanted to show this off. So if you look at this, you have a 3-dimensional object, right? So clearly 2D. And then you have colors. Now what would these colors represent? Temperature, heat. Yeah. So the more red and yellow it is, the hotter it is, and more of the blue and the green kind of stuff, that's colder, right? So distribution of heat is not always the same. You have some kind of heat distribution function. Depends on the object, which will have its own x, y, z equation, and then the temperature, W or capital T, we could have had a capital T equals function of x, y, z. Please note that, let's say it's not going to melt. If I apply fire, right, heat, right here, is it going to be uniform heat everywhere instantly? No, right? It's going to be much hotter here for the water that is close to the edge that I'm heating up than on the other side. So the same thing, the distribution of heat in your engine for the car, or the air in the room, right, when you either apply air conditioning or a heat, whatever. So you need that 4th dimension. How many dimensions do we actually use in formulas? Well, that's determined by the number of variables and parameters that you are observing. Right? Think about the weather models, right? Weather models have a lot of stuff in there. Temperature is just one, right? So we have the location and the rain and the air pressure and the temperature and humidity and I don't know. That should be like, I think, 22 different variables. Right? to observe to come up with the weather model. I'm sorry? Yeah, you all come up with more. So we can have any amount of variables that we want. It's important that one variable, the one that we are observing, is dependent on all the other ones that are independent. Now, the set of all independent variables creates the domain, and the one and single variable that we are observing in the output is called a range, and that one is always on 1D, right? So, as I said, there is some kind of function that will distribute heat through the object that I'm heating up on one end. Now, if I provide a location, XYZ location of the point close to here, I might get, I don't know, 130 degrees, right? And then I provide a point here, different XYZ in the same function, it will compute the temperature to be, I don't know, 96 degrees. So the idea is that we can come up with any function we want from math standpoint, obviously, but then you want to use the useful ones from sciences. Again, cool types of problems for homework. You are to match equations with graphs, and then finally matching level curves with surfaces. Observe there's your saddle point, right? And the cone, and the infinite paraboloid sheet, right? On X. So the level curves on the other side. And my question to you is, which one of these is the saddle thing? Which one of these is the, what do you think?
Bottom left.
Bottom left, very good. The one that goes into an X, nice. Now, you see these two shapes? The one on the left. Stare at one on the left, and then tell me which of these shapes is the one on the left. Nope. It's A. Because you can see that the x-axis is passing in between two hills, or whatever these things are. The x-axis passes in between two hills. Here's the x-axis passing between two hills. Over here, x-axis cuts through two hills. So this one is 90 degrees turned. So this one belongs to there. Probably this one is this one over here, right, with the concentric circles, where it gets larger as you go up. So that's the level curves. Really, there's not much that I can do about this. You have to do some slicing when you get home. So either the egg or the lemon or something, and just, get those level curves. Try to preserve all the fingers. You might need them later. And that's